Alrighty. Hey guys, welcome back to week number 2 of e-learning. Hooray! I'm getting kind of tired of not having a classroom to talk to. I'm like sitting in a room by myself, talking to myself and doing your notes. It is not very exciting, and I miss you all. I would love to like stand up and yell at someone for talking all the time. Haha. But you're not here, so I don't get to yell at you. I can yell at my own kids, I guess, but man, I would never get through class if I had to teach like my 10-year-old and 3-year-old and 7-year-old how to do this stuff. It would be chaos. Like, yeah. So I'll instead talk to my empty room and my headphones and pretend that you're listening to me, hopefully, and getting lots of awesome stuff out of this. So, okay, today we are doing some more graphing. Hooray! Except today we're going to graph linear inequalities. So we graphed equations last week where you had to plot the y-intercept and then use your slope, right? So we're going to do a lot of the same stuff today. We're just going to add on a couple extra steps because now they are inequalities instead of equations. So graphs of inequalities look just like lines, just like we did last week, except now we have to shade one side of our coordinate plane. So with an equation, like if I have y equals 2, right? The only solution for that would be that 2 has to equal 2. There's one answer, right? Because only one thing can equal it. So when we do a line like y equals 3x plus 5, we get just that line, that one single line, and all the points on that line are solutions. Now, if we talk about inequalities, if I say like y is greater than 2, well, I could say greater than or equal to, we'll say. I can say that 5 is greater than or equal to 2, or 10 is greater than or equal to 2. Actually, anything bigger than 2 is greater than or equal to 2, right? So there's a whole bunch of different possibilities for an inequality, not just that one answer that works. So then when we graph something like y is greater than or equal to 3x plus 5, now we're not just graphing the line, we're also graphing everything that's bigger than that line, right? Okay, so that's kind of your differences between equations and inequalities. Okay, so let's then go through, kind of erase all my scribbles up here. Let's go through how to do this and how to graph it, right? Okay, so steps to graph a linear inequality. Here's our original problem, right? 6x minus 3y is less than or equal to 12. Step number 1, just like before when we graphed any line, we're going to put it in slope-intercept form. And then graph like normal. So graph your, let's say plot the y-intercept and then use slope, right? Okay, so starting though, we've got to take our 6x minus 3y is less than or equal to 12, and I have to get that to y equals, right? So I'm going to move the 6x over to the other side, and then we get negative 3y less than or equal to, I'm going to put the x term first because I want it mx plus b, right? So the negative 6x term goes first, and then the positive 12. Okay, and then last step to get y by itself, I've got to divide by negative 3. I'm going to divide everything here by negative 3. That would give me a y. And then negative 6 divided by negative 3 is a positive 2x. 12 divided by negative 3 is a negative 4. Okay, and then I've got my inequality sign, but before I write that down, I'm going to remember that because I just divided by a negative, that's that special rule, right? Anytime you divide or multiply by a negative when you're solving an inequality, you have to flip the sign. So that less than sign is going to switch and become a greater than or equal to sign. So don't forget that special rule with inequalities, very important. Otherwise, you'll have your line backwards. Okay, so now we're going to graph our line, right? So my y-intercept is at negative 4. 1, 2, 3, 4. And then my slope is a positive 2. So I'm going to go up 2. Remember, you can put this over 1 if that helps. So up 2 and to the right 1. Up 2, right 1. And I'm going to go all the way across my graph to fill up this whole coordinate plane. And if I go up 2 and right 1, I can do the opposite. I could also go down 2 and to the left 1. So I can put a point there, right? Okay, next step, draw your line. That sounds like a simple step, but we have a couple decisions to make here. Because we're now doing an inequality, we have to decide if the line is going to be a solid line or if it's going to be a dotted line, right? So you've got two possibilities. It could be a solid line or a dotted line. And the way we decide is by the inequality symbol. So a solid line is if I have less than or equal to or greater than or equal to. Because if it's greater than or equal to, that means it actually includes all the solutions on the line. But if it's just less than or just greater than, then we're going to do a dotted line because it's only the solutions that are more than that line. So we don't want to actually include the line. Now, in this case, we had an or equal to, we had a greater than or equal to. So this is going to be a solid line. Right? Okay, so that's the first new decision we have to make with graphing inequalities. Last but not least, like I said before, we don't want to do just the line. We want everything greater than or equal to that line. So step 3 is to shade, right? If we've got a greater than, right? So if it's greater than or equal to, we're going to shade above the line. And if it's less than or equal to, we're going to shade below the line. Okay, greater than above, less than below. Now, we've done this before. When we shaded before and we had a number line, we shaded to the right or we shaded to the left, right? And the reason we did that is because we were only doing one variable. So we had like x is greater than 2, and the x variable goes to the right and left. So we shaded right or left. Now, when we do equations where we graph a line, it's always the y that's the variable in the front, right? And the y-axis is vertical. It goes up and down. So that's why we're going to do shade above or shade below. So this one, when I go back to this where I just graphed, it's y is greater than or equal to. So that means I want to shade above this line. The easiest way to decide where above and where below is, because sometimes the lines, when they're really steep, it's hard to tell. Go to your y-intercept, right? And then if this was shade above, I'm going to go up the y-axis. So that means I want to shade this whole side of the line, right? Because I went up the y-axis and it was on this side of my graph. So that's where I want to shade. And your shading doesn't have to be perfect. Just make sure it fills up that whole side of the graph, okay, above the line. If it was below, it would be over here. Since we're doing up the line, we're going to go up the y-axis, okay? So same as what we did last week, except now you got to decide, is the line solid or dotted, and do I have to shade above or shade below? Okay, let's try a couple more. If you want to pause and try this one on your own, not a bad idea, right? This one's already in slope-intercept form, so plot your y-intercept, here's your slope, solid or dotted line, and then shade above or shade below. So if you want to pause the video and try one on your own, go for it. Come back, check your answer. Okay, so I'm going to start by plotting my y-intercept. I'm going to go up 1, and then use my slope, which is a negative 2/3. Now remember, that negative sign can only go with one of those two numbers. So it could be negative 2 over 3, or it could be 2 over negative 3. We can do it either way. So the first way, I would go down 2 and to the right 3. I can do that again. Or with the other way, I would go up 2 and to the left 3. Right? Okay, before I draw my line, do I want to do dotted or solid, right? If it's just a greater than symbol, that's going to be a dotted line, right? I just kind of, or dashed, however you want to call it. I don't know. Some people say dashed, some people say dotted. I guess technically I'm saying dotted, but I'm drawing a dashed line. I don't know what's right to say. They both sound the same. I like saying dotted better, but whatever. Okay, so let's shade. Next, right, since it's a greater than symbol, right, I didn't have to do any dividing to change my sign. If it's greater than, I want to shade above the line. So again, go to your y-intercept, go above. I want to shade above this line right there. And all of those points inside of that shaded area are solutions to that equation, right? I could pick a point, let's see, 1, 2, 3, 3. 3, 3, the point 3, 3 is right there. That is inside the shading, right? If I plug that in, I would do, so we have y is greater than negative 2/3 x plus 1. So that means 3 is greater than negative 2/3 times 3 plus 1. That's 3 is greater than, 3's cross out, so negative 2 plus 1. So 3 is greater than negative 1. That is true, right? That's why that point is a solution in that graph. It's in the shaded part, right? That's another way to tell where to shade. Okay, I kind of went overboard there into the next graph. Okay, next one. So this next one, it's not solved for y, so we need to do that first. That means I have to divide everything by negative 4 to get y by itself. So I get y. Do I catch it? We just divided by a negative. It's an inequality. So what do you have to do? Flip the sign in the other direction. So I'm going to switch it this way. And then 8 divided by negative 4 is a negative 2x. Negative 12 divided by negative 4 is a positive 3. Okay, so now we're in slope-intercept form, right? So I'm going to plot my y-intercept. So b is 3, and then my slope is negative 2, and you can put it over 1 if that helps. So up to 3, plot a point. My slope is negative 2 over 1, so I'm going to go down 2 and to the right 1, all the way across my coordinate plane. Or I can do the opposite. I can go up 2 and left 1 across the coordinate plane. Before I draw my line, I'm going to decide solid or dotted or dashed. And because it's or equal to, that means it includes that line. So I want a solid line on this guy. I got kind of curvy there. Let's try that again. Solid line. A little better. Okay, and then lastly, we want to decide where to shade. Oops, I didn't write solid there. So this one again is a greater than or equal to. So that's going to be above the line. This one is one where it's a little bit tricky, but again, go to that y-intercept right there, right? And I want to go above the line. So I want to shade that way. So we're going to shade this in. Okay. All those points over there are solutions to that inequality. All right, the next one. X is greater than 4, right? So this time there's no y variable. Hopefully you remember this from last week. If there's no y variable, then x is always 4, right? That's how you remember what kind of line that is. So I go to where x is 4. It's on the x-axis. And I can change the y value to anything I want, but x is always going to be a 4. That border line is where x always equals 4. So if you want to think about it as a borderline of our inequality, this would be where x equals 4, right? And that would be a vertical line. I could put any other point where x is 4 and change the y value to whatever I want, okay? All right, so then since this is just a less than, it would be a dotted line or dashed. I'm going to draw my line in, but it's vertical. And then to decide where to shade on this one, it's less than, right? But I can't go up and down this time because it's a vertical line. And notice it's just an x. If it's just an x, the x-axis goes left and right. So we are going to think left and right this time. So since it's less than, I'm going to shade, or less than, I'm going to shade to the left. So it'd be this side. This is where x is less than 4, right? If I go pick a point over here, that's x value is 6. That doesn't work. I want where x is less than 4. All right. And our last one here. Again, if you haven't tried one of these on your own, this might be a great spot to stop. Try this one all by yourself, see how you do, and then come back and check your answer. Okay, first thing I'm going to do, I got to get y by itself. So I'm going to subtract the 21 to the other side. Get 3y less than or equal to. Want the x term first, so 5x minus 21. Divide everything by 3. y is less than or equal to. Now, I divided by a positive number that time, right? So I don't have to flip my inequality sign. I'm going to leave this one as a fraction. It's a slope, right? If there's ever a fraction here with a slope by the x, don't change it to a decimal. Keep that as a fraction. And then minus 21 over 3, so that'd be minus 7. Okay, so then we're going to plot those points. Our y-intercept is going to be negative 7, and our slope is 5/3. So 1, 2, 3, 4, 5, 6, 7, right at the bottom there. And then my slope is 5/3, so up 5 and to the right 3. We can do that one more time. Right. Okay, and then before we draw our line, this time we got a less than or equal to, so that would be a solid line, right? And then we got to decide where to shade. Less than or equal to means I want to shade under or below the line. Okay, so I'm going to go to my y-intercept, which is way down here on the bottom, and I want to think below the line, right? Shade down. That means I want this side of our graph shaded in. Okay. All right, there is graphing inequalities, just like what we were doing last week, at the last day of last week, I guess. But now we are doing, you have to do solid or dotted line, and you have to decide where to shade. Only do that if it's an inequality. If it's equals, you just graph the line. Inequality, solid or dotted, shade. All right, homework again today is on delta mass. Let me know if you have any questions. I'll do my best to help out.